first off, so that way I'm not just breaking my back trying to talk to you. I don't think Jiangsu wants to deal with yet another insurance company. So I'm going to sit down here and tell you about Sage. And so for today, this is going to start with something that will be useful for everyone, which is always document your code. I cannot stress that enough because someone has probably told you at some point to do this, and every other person who's taught you programming has told you to do this, and you've probably ignored them, going, yeah, I'll figure it out. I'll remember my code, which is fine a week later, but try it in a month or 6 months or a year later. And you go, how do I do this again? I know I use this code, but now I have to read the code and relearn it, and then I'm not even sure. So what I'm going to start with today is how to write actual documentation for the purposes of Sage. So the formatting here is somewhat specific, but the same principle applies. So in fact, this actually is general for how you should document code in Python as well. There's a few small differences, but Python uses this thing called Sphinx, which automatically builds documentation from doc strings. So what I have here is just a simple function that is available. You can find it on the workshop page if you want. It's the spec modules here. So I've just copied it over into a Jupyter Notebook file. Here I'm running on CoCalc. And so I've already started this and written some documentation for it. So originally it's like, okay, I want to compute spec module. So what is a spec module? It's a representation of the symmetric group, and they're going to correspond to diagrams. Now, if you want the irreducible representations of the symmetric group, then these would be corresponding to partitions, and so you would first try to input a partition to this. If there was like no documentation, this was what I would first try, because it's like, okay, even when I copied this over, I wrote this code. I wrote it probably 2 years ago. No, longer than that, 5 years ago. And it's like, okay, what's the input? And being a good algebraic combinatorialist and combinatorial representation theorist, I would go, okay, it should be a partition. But it's not. And thankfully, I wrote at least enough documentation to verify that that a partition is bad. I need to give it some additional data. So what I've started with, I'm not sure. Yeah, I guess I can pinch blow it up this way. So what I've started with is this doc string. So it's in triple quotes, which is Python speak for I want to do a very long string that spans multiple lines. And because it's Python, it keeps track of the indentation level. So all of these sort of blank spaces here don't really count, but you still need to have. Actually, no, you should not have them, technically speaking, because I could do this, and this is actually just fine because it's a block quote. But it's good to have them indented to have everything match up. And in fact, Sphinx will like it to be this way too. So it could be a single quote, but basically a documentation string for Python is it's a string that is at the very beginning of a function. So it's always that first line. And then what you start with is just a simple one-line description of what the function does. And it should be in this declarative form, so it's return, not returns. This is a convention that Python does and Sage does. But so it's return something, it declares, it's not returns the effect. Technical English point, but just always it's return, not returns. Anyways, and then after that, you could have a longer description. So such as a spec module for diagram D is a representation of the symmetric group Sn, where n is the number of cells of the diagram, up to my ability to type. So if you want to include LaTeX compile, math LaTeX code, what you do is you use the single backtick. So this here is not a single quote, but this backtick. So be aware of that difference. But if you're used to writing LaTeX code and someone has told you about quotation marks, you know what the backtick is. It's the thing on the left for quotes in LaTeX. And so single backticks around something gives it in terms of LaTeX. So it's the same as doing dollar signs or backslash open close parentheses. And you separate lines or you separate paragraphs by blank lines between them. So this here would be one paragraph, and then it starts a new paragraph in the compiled documentation. So if we take a look at, I don't want to do the Portuguese tour of Sage. Maybe someone here speaks Portuguese. I don't. I want the reference manual. And let's go to something that I know. So combinatorics. And let's go to crystals. And we'll look at the catalog. And so, this is what the compiled documentation will eventually look like. And let's look at Keeler Refreshatikin crystals. And so we get things like this. And if we want to look at if you want to look at examples, go to the source code. So I guess the first way to look at source code would be, so you've probably seen the single question mark to get the documentation of something. So you can see down here at the bottom, there's the documentation down there, and it has some formatting that's done to it, et cetera, et cetera. But, and then how do I close this? I'm not entirely sure. But if I wanted to do wow, I'm just creating all sorts of, oh, right, that's why, because I've blown up the screen and I can't see the stupid X. But if you want to look at the source code, including this works for any method, any object in Sage, you do 2 question marks. And we can see, okay, it starts with the documentation, blah, blah, blah. But then we get to the source, and we can see, the formatting here. And okay, I was looking at the Keelerov-Reshetikhin crystals. So let's compare. So here's the source code, and it starts with the source documentation. And we can see the single, there, that's what I want to do. We can see the single backticks around here that corresponds to the LaTeX that's happening here. And then we have these links, oops, wrong tab, there we go. That is linked in this way. So we have some special directives. So colon, func, colon, and then backticks allows you to link to other functions in the documentation for functions. Meth is for method. Class is for class. OBJ for object. MOD for module or file, basically. And this here is slightly special because if I do these angle brackets, the less than and greater than, then this is the actual link that's created, and then the rest can be plain text. So if we look here, we can see that we have Kashiwara Nakashima tableau, but compare this to up here with the module. And back with the documentation, we can see there's just this plain module, and it links directly, and it just has that text directly in it. Whereas this, the link is in this portion, but the text displayed is this portion. And that holds for everything. So, you have your documentation, but you also want to link it to other documentation sometimes, and this is how we can do that. And then we get down to the inputs, where it follows basically a kind of markdown type format. So you don't need to do anything special fundamentally for a bullet list. You just start a line with either a dash or a star, and then you just do that on separate lines. And every start line must begin with the same thing, or begin at the same place, including where the backticks are. And if you want an indented list, you do the same thing, but starting at the indented level. So this sublist here, we can see that it starts at the same line as the, I have a pointer here, so we can see that the line here, they start at the same indentation level. So, and this is something that's needed for it to actually compile, and we can see the output once we compile it. So I'll talk about how to compile it later, but yeah. And then we get to the most important thing, and this is the part really for everyone. Write examples. These are your doc tests. This is how you make sure your code still works. These are things that you are promising your code will work and continue to work. And if they break, that means you need to fix something somewhere in the code, almost certainly in your code. As well as providing examples for how to use it, which is useful for yourself at times too. So here's all of the examples. And if we go back to the source code, we see the format here. So we have examples, and then we have two colons, these vertical pairs of dots. That's called a colon in English. And there's 2 of them. And then the next line, there's a blank line. And then after that, it's indented by 1 level. Typical indentation in Python is 4 spaces. This technically can be anything that you want, but in Sage, we follow the 4-space convention. So, and then to have more text afterwards, you go back to the previous indentation level that you were at. And then there's this extra block called test, which does the same sort of thing. And these are, so examples are if you're writing code to include into Sage and write documentation for including into Sage, you'd have examples that are there in the public documentation, and tests are just private tests that aren't necessarily meant to be shown to the public, because you can see in the compile documentation here, there's examples, and that's about it. You know, there's none of the tests that appear. Any questions so far? All right, so we have the test, then more test, and if you unindent and then again do the double. Anytime you have the double colon and an indentation, it does something special, pretty much. It puts it into that block code formatting. And then here's some references. References in Sage, we'll see how much time we have, but that's a much more advanced topic. Well, maybe it's not that advanced, but basically there's a master reference file, and you link to that with an underscore after in the square brackets. But yeah, I'll get to that in a little bit. But those kind of special directives I'll get to. But the other thing I want to mention, at least for right now, is that the double backticks gives code formatting. And you can see the Carton type is in a slightly different font, and it has some coloring around it. And that's the code formatting. So let's see what else. There's, if you put stars, a single star around stuff, I guess this doesn't have it, you will get italics. And if you put double star around stuff, you'll get bold. I'm trying to think of a place off the top of my head where that actually would occur. Let's go look at permutations. Permutations is always a good place to look. We'll we'll look at this to see how it's formatted, but yeah, let me see here. Long documentation, so, but the documentation automatically sorts it into alphabetical order. But okay, there it has a single, it has italics, so good. That's all I wanted. So if I look at permutation, look at the source code, and It was in the warning, or the note. Yeah, we can see the single star for italics. So then we get to these extra blocks here that have these 2 dots, these 2 periods before it, and there's basically, I guess, primarily 2 special ones that you really need to care about. One is ... warning and one is ... note. I think that's fairly self-explanatory what each is for, so I won't go into it, but again, it follows that same indentation pattern to result in the same sort of thing here. Oh, I guess the third one is to do. There's also to do notes scattered around. They follow the same format, but yeah. And then the other kind of special one, Sage combinat permutation. So we can look at module level documentation as well in the same way. And so this is the source code for the entire file now. And so if you want to find some of the very particulars about what Sphinx does and its formatting, like what these, all of these carets here mean, this is like a subheading. You know, we can compare it back, scrolling up to the top. You know, how we get these header type information like this. There's a few different ways to do that, but you know, these carets are one of them. Oh, and there's the bold, the double star. And we have the bold stuff here. And then, okay, we have tables, which is another ... with special. If you're really writing tables, okay, but for the most part, you'll probably never write it. But again, if you want to if you see examples in the compiled documentation on the website, you can always just go look at the corresponding source code, and that tells you how to do it. So for the most part, like most things in Sage, just take something else that someone else has done, copy it over, and modify it as appropriate. So that is how to write documentation, kind of in a nutshell, all the different formats of it. For the most part, I've presented a lot, but a lot of it is, again, just look at examples and copy it over. That's what I do, actually. If I ever don't remember something, I look at an example, copy it over. But the basic format follows the basic principles of Python. Indentation, 4 spaces, indent when you need to. And otherwise, it behaves pretty similar to LaTeX. A few different things like backtick instead of $, but yeah. So how to write good documentation that's a hard thing, because it's a very subjective thing, but things that you should always include is that very first one-line short description. When it's not obvious, you should include inputs, which will be basically all of the time. Self is never an input. So when you're writing methods, functions that are attached to classes, the first argument is self because it refers to the instance that's being called there. That's never an input unless you have some really special reasons, some kind of restriction on the objects that it's supposed to handle, which good object-oriented programming says this should never be the case. But sometimes it does happen, you need some extra conditions and there's no reason to write an extra class for this. Like, say you want to look at all partitions except the empty partition. Sometimes you don't want to write something for a non-empty partition. This is just wasted time. It's wasted time for you to write it. It's wasted time for people to maintain it. So you sometimes do this, and that would be the one exception for putting self as an input. But generally speaking, you don't want to put it. And then the other thing is every method function in Sage should have a doc test. So that means you write in examples. And, well, I have an example that I've done here. So you just start with Sage, colon, and you put your example, and then you put the output. So here the output is 3. And so if you know what a spec module is, you understand what this code is doing. If not, then you'll have no idea, and I'm not here to explain what spec modules are and how to compute them. But this would be an example, and now I can include this into Sage, at least in terms of documentation, and I'm assuming that I've written the code so that it actually works. So now we have code, and I'm assuming that, well, the next thing would be to test it, and I'll talk about that, how to actually put that into the code properly in my next talk when I actually have Jungsu's laptop and can destroy his copy of Sage with code that doesn't make any sense and doesn't work. But for now, at least, I'm just going to talk a little bit about something a little more technical, which is how to actually contribute to Sage. So there's 2 ways you can contribute to Sage fundamentally. One is to add new code, which is great. It's like, in mathematics, we write papers and we submit them to journals, and that's great. But the other way you can contribute to Sage is to review code. So like mathematics, every code has gets reviewed by a second party. Now, if 2 people write code together, they can cross-review each other's code, but there has to be at least one referee that's not the sole author of the code. So if you write code, you can't review your own code, which, like mathematics, would be horrible. That's not a review. That's saying, I promised my code as well. So what we can do, so I'm on the Sage track server here. So it's track.sagemath.org is the landing page. You can log in. You can get a specific track account, but you can also log in with your GitHub credentials. And then we can look at tickets needing review. And we can see all of the tickets that are looking for someone to review it right now. And I will, this looks like a ticket that I can do really quick. So, or not. But, we have these tickets, and we can view the changes that are being submitted by clicking on the branch here. And we can see the diff file. So this here is just adding a deprecation because we just don't want it to really appear anymore. And we can see some of the changes. Now we can look at the built documentation. So Sage now provides a number of tools that actually does the checking that you would as a reviewer. So if I was doing this myself, I would download the branch into my local copy of Git, compile it, run the test. But I can look at now the built documentation for that. This one's actually quite boring because it just makes one change that doesn't actually appear in the documentation. But it will build the documentation for you. And then there's the patch bot that would run the test. This has not run any of the tests yet, so I'd actually have to do it myself to make sure all of the doc tests within Sage still pass. So I can't actually do that. Let's see if this one has. Nope. What would be one that I can... Unfortunately, the patchpot doesn't always... Let's see if this... Yeah. So here we have a green check mark. That means the patchbot has passed, so I've clicked on the check mark here. And then I can see the build log. The important stuff usually is at the bottom, which is after it loads all of the log, which is not short, but that's the big thing. All tests pass. So that means that someone, this magical patch bot, has taken this ticket, pulled the branch, and run all of the doc tests. It's built the documentation, run the doc test. So everything is good that way. For this, though, it doesn't run optional tests. So this one I actually would need to check myself, unfortunately, because it uses the internet. But I would look at the diff and see, okay, is there anything I need to change, and provide feedback. But I still can't actually test that. Maybe this one will, yeah, okay. So test pass, documentation builds. I could look at the documentation, and so I'll actually do the review right now. So I can see the changes. I can see the file which changes, and then the plus sign is additions, the minus signs are subtractions. It's a diff file. And I look at this, okay, that looks good. The code looks good. I could run additional tests if I wanted to, but this is such a simple thing that I don't need to worry about corner cases or do any additional checking, because it's built upon other code. And so I put my real name as a reviewer. I select positive review, and I say it looks good to me. And this is how you can contribute to Sage. If it doesn't look good, then you could go and change it to needs work or needs info, and explain what needs to be fixed. And this is something that you don't even need to have your own local compiled built version of Sage to do, depending upon how well you understand the code. Or if something doesn't look right in the documentation, or something you want added to the documentation, like the documentation isn't correct, something like that. But the typical process is a standard sort of Git process. You have this branch here, you pull it locally, you build it locally, you make changes, you commit them, and you push them back to the track server. This is the current process. And frankly, I don't think there's anything that difficult with it. You have to get used to a little bit of how to work with Git. But I highly recommend it. It's a great way to write math papers, actually. And you don't have to worry about your Dropbox getting completely full, because it does happen very quickly. And so using something like GitHub to work with papers and having the basic Git skills actually can be very useful because it also allows you to work on stuff simultaneously. So, but that's the very short version of how to contribute to Sage, at least with the current workflow. And I'm happy to talk more detail about that, but probably best to do that on individual by individual basis. But I'm happy to answer any questions right now. Yeah?
So I heard that this maintaining system will be moved to GitHub and
That's the next thing I'm going to talk about.
okay.
Any other questions not pertaining to the move to GitHub? All right. So, yeah, this is the current way. Before I talk about the move to GitHub, I should talk a little bit about adding new code into Sage. So the process, actually, I shouldn't have closed that. The process of adding code to Sage is you create a new ticket. So the current process is you create a ticket and you fill out the summary, short description, implement spec modules. We implement function to compute the dimension and a basis for spec modules as a submodule of the symmetric group algebra. And I'll say for permutation. So then there's the type. It's an enhancement. In other words, it's adding something new to Sage. It's enhancing it. It's making it better. This will be, well, it's somewhere between combinatorics and algebra. So I'm going to choose combinatorics. Give it a keyword. And then I will put myself as an author because I am at least one of the authors for this. And then if I had a branch that I've pushed, I would write in that branch name here. And that would be it. That's all you have to do. And create ticket. So, and this is something that I will, if someone is working on this project, we'll actually go through the details of it. But you can, anytime you have a bug in Sage that you notice, create a ticket. You don't need to have code ready. If it's a feature that you want to add, create a ticket. Again, you don't even need to have code ready. It's a wish list item. Create a ticket. But it's a fairly straightforward process. You just have to do one manual thing, which is copy and paste in the name of the branch into the branch field. But everything else takes care of itself from that point. Similarly, if you're reviewing a ticket and you make reviewer changes and you push them, change the name of the branch. So what we're wanting to do now is to add this spec module code somewhere in Sage. And the question now is where? Because, okay, it's great as a standalone function, but it's not something we want to put at the top level because it's very specialized. And it can, if you start typing S and you hit tab, most people in this room will probably want it to appear, but we're very special. We're not the thousands of other users out there who don't care anything about combinatorics. So we don't want to put it at the top level. It doesn't make sense up there. It's something attached to, say, a partition or a composition or a more general diagram. And so here I have the Sage code that you can find online on GitHub, on its GitHub repository. And the main code, of course, is in SRC, which is short for source. Maybe I shouldn't say that, of course, here, but SRC stands for source, and then maybe I can get away with saying, of course, the source code is in the source folder. And then we go to the Sage subfolder. And for this, we would probably put it in combinates because it's a combinatorial data. And, well, I would probably attach it to the symmetric group algebra and put it as a method on the symmetric group algebra class here. So I would add it as a method here somewhere, and then it would take in a diagram, and I would just need to change my code rather than create the symmetric group algebra. It would instead just check that the number of boxes is equal to the rank. But then I have a good way to add the code. I found a good place to add the code into Sage. This is not always an obvious thing to do, is where to add the code into Sage. But the main thing you want to try and avoid is adding stuff at the top level into the global namespace, because most of the times it doesn't make sense. It's not the first object you create. So if you sometimes, of course, it's the first object you create. A lot of combinatorial gadgets that we like are actual things that would go into the global namespace, because to create a plain partition, for instance, you just start with a plain partition. You don't start with another partition and build something out from there. So there's that, but it can still go into their own separate files. Just find the appropriate folder for it. For most of the people in here, it's either going to be in the algebra folder or the combinat folder for combinatorics. But the structure of the files, hopefully the folder names and everything should be fairly self-explanatory. SF is just short for symmetric functions. CHA is combinatorial Hopf algebras. But other than a few kind of more common acronyms and the abbreviation of combinat for combinatorics, everything else is fairly spelled out, as you can see here. So any questions about kind of the structural setup of Sage and about where to add code or things like that?
Yes, we can also create a new folder on that.
Yep. There's a few technical things with creating folders. I'll go into combinat here. So there's this, you'll need this _init file, which is generally blank, but this is a Python thing that needs to be done. The other is these all files, and that's where the global imports usually go. So you can see, it's importing Koska-Folks polynomials, for instance. Or in the big combinant all, it goes into the subfolders, for instance, here. But the all.py is how stuff gets into the global namespace. And you can see lots of the combinatorial gadgets do those kinds of imports. So. What other questions? All right, so soon, so I've read recently, yesterday actually, that Sage is aiming to move to a fully GitHub development model on February 1st. So what that means is everything is following GitHub's procedures, and there will be pull requests and issues. So tickets will get replaced by issues, and push code will be replaced by pull requests. And basically, these are now completely separate things that have fundamentally no relation to each other that you then have to manually link together, which will be a much more annoying thing that you're going to have to deal with, because you're going to have to manually copy over issue numbers and pull request numbers, PR numbers back and forth. And it's going to be somewhat decentralized, and you're just going to have to deal with it because that's how GitHub works. It's not so well prepared for large projects like this. Large decentralized projects, I should say. Large projects are fine, but we're very decentralized, so it's not well designed for that. But we will have to deal with it. However, it will. So for GitHub, what you do is you make a fork of the repository. That's up here. And so I have a fork of this FindStat project because I did computations to it. But you have a fork, you modify the fork, and then you make that into a pull request. The changes that you want for that based upon a branch that you do locally. And then the merge master will merge the pull requests that have been accepted and tested. The advantage of this, though, is that you no longer need to have a local copy of Sage to make changes. GitHub allows you to make changes directly on the web to particular things. So for instance, not my profile. Repositories, that's where I go. So for instance, let me go to something that's here we are. All right, so everyone can get to see a paper I'm writing, but that's fine. So, okay, source code, but let's see, where's something that I want to change. Okay, that's right. I need to go to I have the pencil here. That's for editing. So I can edit them directly. And so I can make changes directly. So if this was, say, the Sage source code, I don't want to fork it yet because I don't want to fork it up. Anyways, I make a change to, let's say this is the Sage source code, and then I can just directly type in a commit message. I don't need to have anything local installed, and then with the tools, the build bot and the other documentation builder, I don't even need to check it myself. No. Yeah. So, okay. Yeah, so you can see there's even the option for committing as a separate branch and making it into a pull request directly. So this will be the new model, and so if you encounter typos in the documentation, then it becomes real easy to fix those. You don't even need to create an issue for that. It's just a pull request that you say, oh, typo, and go with that. So it should, in principle, become easier to make little changes to things like documentation or corner cases or add examples. Larger scale changes, you'll still want to have local copies to actually test it, because it might take a long time for things to actually work and for the test to run through the automatic tools. As we already saw with the patch bot, it took some time. There'll be, and I think we're supposed to use some CI, some continuous integration with it, but I don't know how that's going to work. A lot of this is still completely up in the air. We're still trying to figure it out. So unfortunately, I can't say too much more about exactly how it's going to work, but it's going to be built around the GitHub development model, and we're stuck with it because we're going to GitHub. So yeah, I guess that ends talk 1. Any questions about that? If not, then 10-minute, 12-minute break. Start at 10 after.